Assalamu alaikum. In this video, I'm going to explain selected questions from the exam coverage for grade 9 advanced term 3. Let's get started. I will start with this question. Point Q with coordinates 4 and -7 is rotated 270 degrees clockwise about the point 5 and 1. What are the coordinates of its image? Well, in the rotation lesson, we have learned 3 types of rotation. 90 degrees counterclockwise about the origin, 270 degrees counterclockwise about the origin, and finally 180 degrees counterclockwise about the origin. So, in this question, they asked about different type, which is 270 clockwise about a point that is not the origin. That point is not the origin. So, what to do in this case? Well, firstly, keep in mind that 270 clockwise is the same as 90 degrees counterclockwise. So this is the first information you need to keep in mind. Second of all, the center of rotation is not the origin. So in this case, we need to apply translation. Why do I need to apply translation? Let's sketch the point of the origin, or the center of, the center of rotation, which is in this case 5 and 1. 1, 2, 3, 4, 5, and here is 1. This is the point. That point is going to be shifted 5 units left and 1 unit down in order to reach the origin. So I wish if the center of rotation is the origin, that's why I'm going to apply translation. So that will be the first step. Translation by the vector -5 and -1. -5 because I'm going 5 units left, -1 because I'm going 1 unit down. Then we're going to apply that translation on the given point in the question, which is 4 and -7. So 4 -5 -7 -1. The point is going to be -1 and -8. Second step. Now I will be able to apply the 90 degrees counterclockwise rotation. Let's remember the rule of it. The rule of that rotation is, if you have the point X and Y, the change that you will apply is, you will change the sign of Y and then you will switch the coordinates. So you will get -Y and X. So I'll be applying that rule on the last point I got here. So I'm going to change the sign of Y. It is -8. Now it will be 8. And then I'm going to switch the coordinates. So I will get 8 and -1. Thirdly, we need to undo the translation. We need to cancel the effect of the translation. So what will I do? I'm going to apply another type of translation. But now, by the vector 5, +5 and +1. So 8 + 5 -1. The final image that I will get is 13 and 0. So Q prime is going to be 13 and 0. And that is the last solution. Question 11. A circular dial with the digits 0 through 9 evenly spaced around its edge is rotated clockwise 36 degrees. How many times would you have to perform this rotation to bring the dial back to its original position? Well, when we ask about how many times would we have to perform a specific type of rotation, here we are asking about the order of rotation. To find the order of rotation, you need to keep this relation in mind. The relation is the magnitude of rotation is going to be 360 degrees divided by the order. In this question, the magnitude of rotation is given, which is 36 degrees. So I'm going to replace magnitude by 36 degrees equals 360 divided by the order. The denominator here is 1. All what you need to do is cross multiply. So the order is going to be 360 degrees divided by 36, which is, so the answer is 10 times. Next. Let's solve that question. Under a rotation about the origin, the point A, 5 and -1, is mapped to the point A prime 1 and 5. What is the image of the point B, which is -4 and 6 under this rotation? Well, what I know about this rotation is the center of rotation is the origin, which is good. But I don't know which type of rotation is that. I need to identify the type of the rotation firstly. How to do that? Let's write the point A, which is 5 and -1, and its image, which is A prime, the point 1 and 5, and try to discover the change. 5 is the x coordinate, and -1 is the y coordinate. Let's see what change I applied. As you see, the change of -1 is changed to +1. So we changed the sign of y coordinate. And then, as you see, we switched the coordinates. So that is the x and y will be -y and x. This is a 90 degrees counterclockwise rotation. Counterclockwise rotation. So I'm going to apply the same rotation on the other point, which is B. B is -4 and 6. So all what you need to do is just to change the sign of the y coordinate and switch the points. So you will get -6 and -4. So this is B prime. So very important note to keep in mind, always change the sign of the coordinates and then do the switching. So that's it for that question. Next. Design. Camilla is designing a new image for her cell phone case. If the measure of the angle ABC, that angle here is 35. And the measure of the angle BAC is 29. BAC, which is that angle, is 29 degrees. And there is another information that the angle ACB, this angle, which is missing, as you see, is congruent to the angle DEB, which is that angle. Also, it's not given. What is the measure of the angle DEB? So they are asking us about the measure of this missing angle. Well, if you find the measure of the angle ACB, you will easily say that since these two angles are congruent, so the measure of angle BED is going to be exactly the same as the measure of the angle ACB. Okay, what theorem we are going to use here? Obviously, we're going to use triangle angle sum theorem. And that theorem says that the measure or the sum of all the measures of the angles in any triangle is 180. So I know that 29 degrees plus 35 degrees plus the measure of the angle ACB is going to be 180. So all what I need to do here is to add 29 and 35, subtract the sum from 180. So 180 minus 29 plus 35. The answer is going to be 160. So the measure of the angle ACB is going to be 116 degrees. And since the angle ACB is congruent to the angle DEB, then their measures is going to be equal. So the measure of the angle DEB is going to be 160. And that's it for this question. Next. Let's try to solve proof question. Given that angle A is congruent to angle C, angle D is congruent to angle B, the side AD is congruent to CB, the side AE is congruent to the side CE, the side AC bisects the side BD. Prove that the triangle AED is congruent to the triangle CEB. So that is considered easy question because as you see, we know that angle A and angle C are congruent, angle D and angle B are congruent. Also, we know that as the side AD is congruent to the side BC, also it is given that the side AE is congruent to the side CE, and by the definition of side or side bisector, the definition of bisector, I can easily say that the line segment DE is congruent to the line segment BE. So, because all the elements in the first triangle is congruent to the elements in the second triangle, I can say that these two triangles are congruent. So how to write that? So start by writing the given. As you see here, start by writing the given. And then you need to show that this angle, the third angle here, is congruent to the third angle in the second triangle. Why is that? What is the reason? The reason, these two angles are vertical angles. So this is the vertical angles theorem. Then I can conclude that DE is congruent to BE, since this is the definition of segment bisector, as I said before. Finally, I can say that these two triangles are congruent, which is the information they want us to prove, since this is the definition of congruent triangles. And that's it. So this is a complete two-column proof. In these questions, we need to explain whether there is enough information given in each figure to prove the triangles are congruent using one of these methods, SSS, which means side, 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 or SAS, which means side, A side, or side, angle, side. Okay, so let's find out. As you see here, it is given that the side GL and the side JL are congruent, since they have that mark. And the side HL is congruent to the side KL, since also they have the same mark, as you see. And in addition to that, I can easily notice that this angle is congruent to this angle. So let's assume that this is 1 and this is angle 2. I can say that angle 1 is congruent to angle 2. Why? What is the reason? These angles are vertical angles. So in this case, can I use any of these methods to prove that these triangles are congruent? The answer is yes, I can use SAS. So I can write the angle JLH is congruent to the angle JLK because these angles are vertical angles. So these two triangles by SAS are congruent. And it is very important to write the congruency statement correct. The triangle GLH is congruent, as you see here, to the triangle JLK. So that order here is very important. I can directly identify that the angle G is congruent to the angle J. So again, keep in mind that the order here is very important. You need to write the congruence statement correct. Next, let's look at that question and check if I can use any of these methods. Well, QS, as you see here, QS is a common side between these two triangles. And that side, QR, is congruent to the side ST. And that's it. There is no information whether these two sides are congruent. No information if this angle here is congruent to this angle here. Also, it's not mentioned, it's not given that the side QR is parallel to the side TS. So in this case, I'll say, no, it is not known whether QT is congruent to SR, so I can't use SSS. And none of the angles are known to be congruent, so I can't use SAS. Here in these two triangles, we see that AC is a common triangle, is a common side between these two triangles. So it is congruent to itself. I can write that AC is congruent, the side AC is congruent to itself. Okay, and in addition to that, it is given that AC, the side AAB, is congruent to the side DC. So these two sides are congruent as well. Also, it is given that the angle A here is congruent to the angle C. So what comes to our mind is a SAS, side A side, or side angle side. Okay, so in this case, I can say yes, this side, as we mentioned, is congruent to itself, and this is a reflexive property of congruence. And so the angle here is congruent to this angle. So I can say that the triangle ABC is congruent to the triangle CDA by SAS. Next, let's look at these two triangles. It is given that the triangle here is a right triangle. So this is 90 degrees. 90 degrees triangle. The same thing here for that angle. That angle measures 90 degrees. So these angles are congruent. It is given also that this angle here is congruent to this angle here. So I can easily conclude that the third angle here is congruent to the third angle here. The problem is nothing is mentioned about the sides. So I can't say that these two triangles are congruent just by AAA or angle, angle, angle. That can be used to prove similarity, not congruency. So in this case, I will say no, both the triangles must have 3 pairs of congruent angles from the third angle theorem, but no side lengths are known. So we can't prove the triangle congruency. Yeah, probably I can prove the triangle, or for sure we can prove the triangle similarity, but here we are not talking about similarity, we are talking about congruency. So the answer is no. And this question, let's try to write a different type of a proof. We have learned how to write 2-column proof, but actually this is not the only type. We have many types. One of these types is flow proof. Flow proof. So how to do that? It is given that the side JK is congruent to the side MK. And the angle L is congruent to the angle N, as you see here. And directly, I can notice that this angle is congruent to this angle. And actually, the reason is known now for you guys, because these two angles are vertical. So this is a vertical angle here. We need to prove that the triangle JKN is congruent to the triangle MKL. How to do that? So the idea of flow proof is very easy and clear. You need to list the given statements, as you see here. Write also the information that you found, which is that angle JKN is congruent to the angle MKL, and write the reason below the information, the key information you have found, because these angles are vertical angles, and all these statements will lead to the conclusion that I need. The conclusion is that these two triangles are congruent. And why is that? Which method is that? This is angle side method or criterion.
At the end, I would like to thank my colleague, Tanvi Rihani, for creating the PowerPoint. Hopefully you find it useful. Thank you for watching.